Greetings, guys. We're going to take a walk down memory lane and talk about some special triangles. Okay? This is from geometry. They made you guys go through something. Hang on, I'm trying to draw a really nice one. There we go, looking good. What I'm trying to draw for you is a 30, 60, 90 right triangle. Now a 30, 60, 90 right triangle has a certain fixed set of values you will always get from a 30, 60, 90. They made, well, in my book, they use S. Like they say opposite the 30-degree angle is S. Opposite the 60-degree angle is S rad 3. And let's just see if anybody remembers this before I write it down. What is opposite the 90? 2S. Now, I'm going to do 30-60 first, then I'm going to do 45-45, but we're not going to be doing it the same thing as we did in geometry. See, in geometry, let me give you a little blast from the past memory thing here. Back in geometry, they said something like this. Here is a, come on, 30, 60, 90 right triangle, and I am going to tell you that the measurement over here is 3. And then they said, can you find the 2 other missing pieces? And you would say, oh, I don't remember how to do this. Well, which piece of info did they give me? They gave me the 3. So the 3 is opposite the 60, which means it's equivalent to this guy. The ratio says that piece is the S rad 3 piece. Can you solve for S? And I say, yes, I can solve for S. I just divide both sides by rad 3. And then this would cancel, and I'd get S is equal to, and I go, oh, wait, I'm not supposed to leave rads in the bottom, so I multiply this, right, and this by rad 3. And then what do I get? I get 3 rad 3 over 3. And so I can reduce, because they're outside numbers, just like they were in the last lesson. I go, ooh, reducible. So what's the missing piece over here? Well, that's the part opposite the 30, so that answer would be rad 3. So I go, oh, you know what? So I can take, I'm just going to redraw it so it's not so messy. Here we go. So when they started me off, what did they tell me? They told me this piece here was 3 units. So that means I found this piece, because that's rad 3. That's what S is equal to. And then I say, wait a minute. If that's what S is equal to, then 2S would mean 2 times that. There's 2S. There's 2S right there. This is something they taught us in geometry. What we are going to be doing with this, though, is we're going to be applying it to trigonometry. In trigonometry, what they're going to ask me to do is they're going to say, hey, could you find the sine of that 30-degree angle? Could you? And I go, sure I could now, because I have the opposite over the hypotenuse. I have that. I could say opposite over hypotenuse. I could totally find the sine of that 30-degree angle. Ooh, wait a minute. These are both inside numbers. I could reduce. What holds the place on the top for me? 1/2 does. Oh, so the sine of 30 is 1/2. Do I write 0.5 for an answer? No. I never use decimals in trig. It's either whole numbers, fractions, or radicals. But here's the thing with this. I wanted to show you guys what they taught you in geometry. And I wanted to show you I could find the sine of a 30-degree angle that I just finished. But here's the real deal. When you take the sine of a 30-degree angle, no matter what, if it is a 30-degree angle, your sine answer is always going to be 1/2. Well, what about cosine? What if I did cosine? Well, your cosine answer for that 30-degree angle is always going to be rad 3 over 2. Always. Well, you didn't even show the steps. I know I didn't show the steps. I don't have to show the steps. Well, how not? How come you don't? Well, watch. If I did do cosine of 30, it would be adjacent over hypotenuse. I would say, wait, there's a rad 3 there. I'm going to get that out. And then on the bottom, I would have, well, rad 3 times rad 3. That's rad 9. Well, that is 3. So I have 2 times 3 in the bottom. That's 6. And then I have a 3 rad 3. And then I go, oh, 3 goes into 6 twice. What? There it is. Now, I'm not doing this by magic. I'm not. I'm about to show you that it's always true. A sine of a 30-degree angle is always going to be 1/2, no matter what. The cosine of a 30-degree angle is always going to be rad 3 over 2, no matter what. The best part is you really do not have to memorize these answers. You don't. Let me show you what's going on. Let me show you. This is where we get a little bit of theoretical, but I'm going to draw my 30, 60, 90 triangle. Come on. This guy's 30. This guy's 60. Here's my 90. And I go, oh, this is S. This is S rad 3. This is 2S. So if I wanted to find the sine of that 30-degree angle, look, opposite over hypotenuse. The S's would cancel. What holds the place in the top? I get 1/2. If I wanted to do the cosine of 30 degrees, that would be, hang on, let me get rid of this arrow. That would be adjacent. Oops, sorry. That would be adjacent over hypotenuse. The S's would cancel. Bam, I get rad 3 over 2. I do. What about tangent? What's the answer for tangent? It's rad 3 over 3. What? The answer for tangent of 30, look, it would be opposite over adjacent. And then I'd go, the S's cancel. And I'd get, I got to get the rad out of the bottom. Rad 3 over 3 is the answer. See, here's the deal with any 30, 60, 90, and it's going to be true when I show you the 45-45 problems. The S's will always cancel because I'm doing trig ratios, and no matter what ratio I do, I'm always going to end up with a little s in the top and a little s in the bottom. Little s in the top, little s in the bottom, little s in the top, little s in the bottom. What's going to happen? The S's cancel every time. So here's the trick we use in trig. We don't do this in geometry. We do this in trig. For every 30, 60, 90, we think of it this way. Instead of 30, let's just put a 1. Instead of 60, let's just put a 1 rad 3. Instead of 2s, or opposite that, we're going to put 2 times 1, which is 2. See, I don't even have to write this part in. I can simplify it. I can streamline it. What am I doing? I am mentally saying, I don't need the S's there, because if I do sine, the S's cancel. If I do tangent, the S's cancel. If I do cosine, whatever. So the same thing goes with a 45-45 right triangle. Now the good news is we don't have to go through a ton of stuff for this because we just went through a ton of stuff for that. So let me just draw to the best of my ability a 45-45 right triangle. Now back in the day in geometry, they said opposite the 45 is S. This is a congruent angle, therefore this is S. Opposite sides of congruent angles are congruent. And then opposite the 90, we called it S rad 2. Well, guess what we're going to do in trig? We're going to say, you know what? If I do any of the trig ratios with this stuff, any of them, pick one. What the heck? If I did tangent of 45 degrees, guess what I'm going to get? Well, pick either one of these. They're both 45. So that would be opposite over adjacent. What do I get? 1. Why are we using all these S's? Let's just say, let S equal 1. Always they're going to end up canceling. I'll get a 1 over a 1. So in trigonometry, we streamline this stuff. We don't say S. We don't say S rad 2. We just say rad 2. That's a 1. That's a 1. That's what we do. Now, let me get this out of the way. Come on, come on. Because these are the two dudes we want to use for the rest of our time together. For the rest of our time together, we are going to run into these guys so much that you are going to have the answers actually burned into your brain eventually. You really will. I can't prevent it from happening. It will just happen. So what am I talking about? Well, they're going to do something like this. Find the cosine of 60 degrees. And I go, okay, that means use this triangle. Don't use the 45-45. And if I did the cosine of 60 degrees, I would say, well, that's adjacent over hypotenuse. Oh, 1/2. What if they said, find the tangent of 60 degrees? I would say, oh, okay, let me remove those arrows I just drew in. Oh, God, I got rid of that. Now I can put that back. Well, opposite the 60, adjacent to the 60, what would the answer be? It'd be rad 3 over 1, but you don't have to write the 1 if you don't want to since it's in the bottom. So I'm not gonna. There's my answer, rad 3. What if they wanted to know the cotangent of 60? What? They're going to do that to me too? Sure. Well, then now I want to kind of visualize it. I want to think, oh, it's the reciprocal. Oh, I can't leave the rad in the bottom. Heck, I got all kinds of stuff bugging me now. But the answer would be rad 3 over 3. Exact values. We always deal in exact values. Okay, well, what if they wanted to know the cosecant of 45 degrees? Well, here's where it gets weird. I am a math guy. I love math, I really do. But my brain does not think in terms of cosecant right off the bat. It doesn't. I do not think in terms of cosecant. But I do know this. It's the reciprocal of sine. So here's what I always do. I just go, hey, I'm going to find the sine of 45. So I pick one of these. That would be opposite over hypotenuse. And then I say to myself, wait a minute, the original question, they didn't care about that. The original question, they wanted the cosecant of 45. Well, what do I do then? I just flip my answer over and I'm done. Bam! Shazam bam! Now here's the deal, guys. You can punch stuff into your calculator. You can go tangent of 60. But you know what it's going to do? It's going to give you a hideous decimal. And no matter what, your decimal will not go back into anything other than a decimal. You try it if you want. You grab your grapher like I got And I go, tangent? Well, wait a minute. This is the first time it's ever mattered. This is the first time it has ever mattered to us. If you hit the mode button on your graphing calculator, its default setting is radian. So if you want to be in degree mode, you got to make sure you're in degree mode. So I go to, I'm going to change it to degree mode and let my calculator do all the math for me. So I'm going to do, what was I doing? Tangent of 60. So I go tangent of 60 degrees, and my calculator says the answer is 1.732050808. And if I hit math frac, I'll just go math frac. It says the same thing because it cannot do anything with this number. Why? Because that number is irrational. Guess what that number is? Well, go to your calculator and punch in the square root of 3. And guess what? You're going to see the exact same number pop up. And you go, oh, well, I'll math frac it into a radical. There isn't anything on your calculator that will do that. And when we get farther into the book, you're going to wish you just paid attention here and muscled through this. Because here's what your assignment looks like. I'm going to go up there. But before I do, I want to make sure I box this off. When we are evaluating trig functions that contain 30-degree angles, 60-degree angles, or 45-degree angles, we use these two reference triangles. These guys here are called reference triangles. We refer to them to get our answers. That's why they're called reference triangles. Now, this is the assignment. Whoop, I want to get a black pen. Okay. Look it up here. Look it up here. Look it up here. See, the name of this lesson is Special Right Triangles. It says for each expression, give the exact value. Exact value is never a decimal. Here's the answer key, by the way. Look at it. Do you see one decimal there? I do not. I do see a whole number. I see a 2 here. I see a 1 here. But not one decimal, baby. No way. You write decimal answers for trig functions, and kids at math camp will tease you so mercilessly. They will say, oh, was your calculator set to radian mode or degree mode? And it's no fun getting hassled by the kids at math camp. So look at our questions. What's the tangent of 30? Guess what? You're going to go look at this reference triangle. Look, you're going to go down here. If you haven't already jotted this down in your notes, and you're going to go, hey, anytime they ask me about a question that has a 30 or a 60 in it, I'm going to look right here. Tangent of 30, it's 1 over rad 3. But then I have to rationalize it. Let's go up again. Problem number, the cotangent of 30. Heck, I just did problem number 49. Could I just take that answer and flip it over to show them the answer to 50? You betcha. Huh? You betcha you could. All kinds of fresh moves in this. So take a look. I need you to start with the most basic principle before we get messy. These are all either 30s, 45s, or 60s. But, you know, they got some fresh moves here like secant 45, cosecant 60. So, this assignment, you got 49 to 64. This is, by the way, page 52 of the trig book, just so you know. If you don't have a trig book, don't worry. This is what I want you to do, and here's the answer key to it. No matter what, I never assume you have a book. They didn't have one in the library. I left it at my friend's house. Whatever. I never assume you have a book. I just say, you know what? You cannot say, I couldn't do the homework. I didn't have a book. Because I always put the homework here. Okay, so guys, good luck. And remember, if you get stuck on anything, ask me. I'm in the Zoom room. All right. Bye-bye.